Okay, so good morning, everybody. Just let me know quickly in the chat box if I'm audible and the screen is visible to you. Yes, everyone. Am I audible? Okay, thank you. Fine. So, since we have started on a very short notice, so let us wait for 2 minutes so that everybody could join. Yes, one more thing, you should keep your pen and copy ready so that we can solve a few numericals, right? Otherwise, it will be difficult for you. Only if you see and if you will not solve, that will not solve any purpose, right? So you have to solve the questions also. We have to discuss a lot of things. Okay, fine. So let us begin this discussion today. So we were talking about regular expressions in the previous class. So what I said is, uh, you know, mm, let me share my whiteboard. So what we have discussed yesterday is regular expressions are, you know, yes. So uh, in center we have drawn yesterday one diagram. In center we have said that regular languages are there, right? And there are acceptors, or there are machines which we have already seen, we have designed. Basically they are called finite automata, and these machines are basically nothing but acceptors, right? They are basically accepting the regular languages, acceptors. Okay, fine. And what we have said is, like, the definition of regular languages can also go like this. Like, we can say that, what is a regular language? A regular language is a language which can be accepted by a finite automata, right? If we cannot construct a finite automata for a language, then that language is not regular, right? It is as simple as that. So if we can design a finite automata for a language, then we can say that that language is a regular language, right? If we cannot design a finite automata for a language, then we will say that that language is not regular, right? Okay, so in finite automata, we have divided it in NFA, DFA, right? Without input, without output, and with output. So without output and with output. So in without output, we have seen NFA and DFA, right? Where we do not have any output, only acceptance or rejectance is there, using these two finite automata. Then with output also, we will see in the second module only, we will see there are two finite automata where we will see it is with output. That is, one is called Moore machine and one is called Mealy machine, right? Moore and Mealy machine. So we'll see about this in this module only, Moore and Mealy machine. So that will be the finite automata with output, right? Till now, what we have seen is finite automata without output, right? So NFA and DFA we have seen, and we have seen that we design these finite automata for regular languages, right? There was one more thing we talked about yesterday in yesterday's class, that there are generators, which is called grammars, right? So in this module only, I'll be talking in detail about grammars, right? So these are nothing but generators of regular languages, generators, right? So grammars basically generate the languages, right? So for regular languages, we have regular grammar. For PDA, we have context-free grammar, right? For context-free languages, we have PDS, basically, context-free grammars, right? And machines are PDA, right? Similarly, for recursively enumerable grammar, we have a Turing machine as the machine, right? and grammar is recursively enumerable grammar, right? So grammars are basically nothing but generators of the language, right? Okay, so that's grammars we have seen. We just have discussed. We will see in detail Chomsky hierarchy of grammar. We will see. Then the next thing yesterday we talked about is regular expressions, right? What is a regular expression? Basically, a regular expression is nothing but, you can say, a representation of regular languages, a mathematical representation, right? So like arithmetic expressions, we have regular expressions. So like in arithmetic expression, we represent arithmetic expressions with the help of operands and operator, right? So yesterday we have also seen like arithmetic expressions, how we write arithmetic expression. We write like something, let's say 2 plus 3 minus 5 multiplied by 9, something like this. So here two things we have. One is called operator, that is this plus this, multiplication, this minus, this is called operator, right? And there is something called operand, right? So these are called operands. Similarly, we have uh, a regular expression like arithmetic expression. We have regular expression, right? Regular expression. In regular expression, we write something like this, like a plus b closer, right? So here, if you see here, this plus and this closer are called operators. So they will be called operators. And these strings like this a b, these will be called operator or operands, right? So similarly, like arithmetic expression, we have regular expressions like this, right? Then we have seen in the last class that there are basically four operators we have. One is this dot, we call it concatenation, right? Or and, right? So two three names we said yesterday. This dot is called concatenation. Then this plus was called union, right? Then if we put this star on the power of something, then this is called lean closer. KL, lean or clean, whatever you pronounce it. It is lean closer, right? And then if you put a plus over this, this is called plus closer or something, right? So lean closer is what? Zero or more time, right? Zero or more. This means zero or more. And this is called plus closer. And this is, you can say, one or more, right? Concatenation, you can say and, right? Concatenation is also meaning something and, right? And union means or, right? So these are the four operators by which we will be writing our regular expressions, right? Okay, so that's what we have discussed yesterday. So last language which we have been discussing yesterday was, I think, at least two, right? So we have said, and one more thing we have said, that in all these examples, we will consider that sigma, that is set of input symbol, is A and B only, right? Until we say something about it. Until then, you consider that input symbols are A and B only, okay? So yesterday, we talked about some regular expressions like starts with a, ends with a, or ends with b. So let's say for starts with a, so a language starts with a, how we can write it? So it should always contain a at the beginning, right? So starts with a should contain an a, and along with a we can have a, after this a we can have any number of a's and b's, right? And we have also seen that for this kind of regular expression we can design finite, we have already designed finite automata also. How we have designed finite automata? We have said fine, from the initial state we should get a, right? So most of the time I'll be designing NFA with epsilon mode, right? So from initial state, on getting A, I will go to the final state, right? And then I can have anything A's and B's, no problem, right? If I design a DFA, then I have to design a dead state for B, but I'm not designing DFA. Let's say in that case, this will be the dead state, right? So this is what starts with A. This is the regular expression for starts with A, right? Similarly, yesterday last question we were discussing what? Uh, at least 2A, I think. At least 2A or something. Or chalo, fine. Let's discuss about this at least 2A. So yesterday we were talking about string W where uh, the length of the string is at least 2. Or first of all, let us talk about the length of string is exactly 2. So what is how we design how we write the regular expression for the length of string exactly 2, right? So for exactly 2, what we have to do? For exactly 2, we will say first symbol you can get either A or B. Plus means or, right? Union. Either A or B you can get. After this A or B, again you can get either A or B. And since the length of the string has to be exactly 2, this will be the regular expression. What will be the regular language for this? Exactly 2. So it is AA, AB, BA, and BB. So this is the language for length of the string exactly 2. And every time remember the input symbol we are just talking about A's and B's. Right? So this is the regular expression for exactly 2, length of the string exactly 2. At most 2, let's say at most 2. Can somebody tell me how to design for at most 2? Hmm? At most 2 means what? First symbol can be A, it can be B, or it can be, I mean, it can be epsilon as well, right? At most 2. At most 2 means what? What will be the language? At most 2 means what? Epsilon, yes, correct. At most 2 means epsilon A, B, AB, and BA. Correct, Richard. So the language will be what? At most 2 means epsilon, only A is possible, only B is possible, A, B, and BA. This is the only. So it is a finite or infinite language. Can you tell me whether it is a finite language or infinite language? Mhm. Finite language, correct. So you can design from this, in case of finite language you can design from the set also. Like here, if you want to design for this, how you can design? You can take A common from this, and you keep on plus, like from A and AB. If you take A common, then it will become A plus A or B. Yes or no? From this, if you take B common, then it will become B, A plus B, right? And then if you take this separate, it will be A plus B, A plus B. Now, second important thing which I'm telling today is, like yesterday, some of you have written, other finite automata. You have said that I can add one more epsilon. Is it not possible? I said yes, it is possible. So whatever regular expressions I am writing, it is not the unique regular expression, or I am not saying that by any mean this is the only possible regular expression. You can write your own regular expression, and that is perfectly fine. Two people can have more than one finite automata, two people can have more than one regular expression, and that is perfectly fine. And in case of finite automata also, I told that minimum DFA will be same for, has to be same for everybody. But if you design a finite automata NFA or epsilon NFA or DFA, then everybody could get different machines, right? That is perfectly fine. Okay, fine. Anyways, so at most 2 means what? So either I can get single A, single B, or epsilon, or what I can get? I can get two A's or two B's or epsilon, right? So this is covering everything, right? This is covering everything. Either I can take one A from here. So AA is covered, right? AA is covered, right? Either I can take one B from there. So BB is covered, BB is covered, right? So this is also possible, right? This is also possible. Then what I can do? I can take epsilon from both. Then epsilon is also covered, right? A, B, B covered. From first we can take A. From second I can take B. So A, B is covered. From first I can take B. Second I can take A. So B, A is covered. From first I can take A. From second I can take epsilon. So A is covered. From first I can take B, or second I can take epsilon, so B is covered. All these are covered on this regular expression. A plus B plus epsilon concatenation. Concatenation we generally do not show. You can write it also. Concatenation with A plus B plus epsilon. Now, if I want to design a finite automata for this, then how can we design? So it is very simple. For this, I am designing. Let me clean everything else. If I want to design finite automata, right? For this, if I want to design a finite automata for this, then what I should do? I should, from the initial state, at most two, no? So we have already designed actually. We have already done it in the class. So at most two means from initial state, I can get either an A or a B and go to the next state, right? I have to count two, right? So again, from this, I can get either A or B. So that will be count two. And then I will reach to my final state. So that is at most two. And one more symbol I need, that is what? Or I can optimize this. I can have only two states. Let me make it like this. Yes, I can make it in two states. That is not required. You can make in three, four state also. That is also fine. And this, right? So this is accepting everything. Uh, Initial state is final state, so epsilon is accepted. Then one AB, if you get, oh, at most two, right? So one AB is also fine. So what I should do from initial state, first of all, epsilon is accepted, so initial will be final. Then what I'm saying is I will be going to another state at most two, no? So I should not get anything more than two. So simple, I will make it simple. Let us not optimize it. So simply I will go to the next state. That will also be final state. And then I can go to the next state. That will also be final state. And that is saying at most two. Let us not do this, because in this we can repeat AB. Now here I cannot repeat AB, right? So this is simple, I mean, finite automata. Here what all I accepted: epsilon is accepted, single A is also accepted, double A is also accepted, but anything more than that I am not taking, right? I'm not designing for this. So this is an valid epsilon and no problem, right? Fine. So you can optimize it. You can make your own in your own way. That's what I'm saying. So at most, this is what is at most. The length of the string is at most two. So the length of the string is at least two. Yesterday we were talking about this. Length of the string at least. So we how we can write it? Length of the string means mod w is at least two. At least two कैसे बनेगा? Who can tell me? Just raise your hand. At least two. Anyone? At least two means what? First of all, AB, BA, BB, AA, dot 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 means yes, minimum two. Correct, correct. At least two means it is an finite or infinite language, Richard. Finite language or infinite language? Infinite language. Correct, correct. Infinite language. Now, what all are valid? Anything more than or equal to 2, right? So AA, BB, AB, BA, then AAAA, BAA, BA, AB, anything. I mean, anything more than 2. So can somebody tell me how you can design the or regular expression for this? What will be the regular expression for this? Take your paper, copy and pen, and try to write the regular expression for this. Hmm? It is actually very easy. What we have to do? So at least length has to be at least two. So first we can get either A or B. Second, I can get either A or B. Then I can get anything more than that, right? So I will say after this, I can get any combination of A's and B's. That's it. Uh, yes, Ansi, I think you are also correct. So what Ansi has said, see, it is also interesting. What Ansi has said, instead of this is also correct. Ansi is saying A plus B, and after that A plus B to the power plus. This is also correct. This is, you can write this, right? A plus B closer concatenation with A plus B, you can write A plus B plus, right? Yesterday we have seen. You are correct, Ansi. Right? You got it, everyone? Hmm? At least two. The length of string is at least two. Exactly two we have seen. Length of the string is even. Can you draw this? Even length, the regular expression. Even means we are saying that mod W is even. Mod W is even. Yes, anyone? Even means whether zero length or epsilon is accepted. Zero length. Epsilon means not exactly epsilon, but we can say that zero length string is also accepted, right? Hmm? Correct. So can you tell me for even length, when the length of the string is even, how do we write this? Really simple, right? What we can do? First character we can get either A or B. No, no problem. It is not any constraint. It is not saying starts with A or B. So it can start with A or B. Then second character we can get either A or B. No problem. The only thing, either it should be repeated zero or more time, right? So closer on that. That's it. Done. Do you follow this? Length of the string is even. Is that clear? Hmm? Is there a doubt? Length of the string is even. Come on, do it for odd. Now, if it is clear, then do it for odd. When W is odd, W is odd. Do it for odd. Length of the string is odd. Length of the string is odd. Mm, A plus B closer. No, it will not be saying it is odd. No, A plus B closer means it can be zero or more time. So it is not either saying even or odd. It can be anything. A plus B closer means even, odd, anything. I just want odd. Do you understand? Odd means minimum how many times it should come? Minimum one time, right? Hmm? So what we can do, even plus one is odd, right? So I can just modify this only. You can write it in your own way. That's not a problem. What I can do is I can take this even length, right? And I can modify this for this, right? Now this is the regular expression for odd length strings, right? Odd length string. Now here, what is the minimum string? Minimum I'll get either 1A or 1B. So this is for, because of this, I will get at least 1A or at least 1B. Yes or no? After this, I can get any number of any even pair of A's and B's I can get, and along with that, it will become odd, right? So this will be saying like the length of the string is odd. Is that clear? Hmm? Is that clear? Any doubt is till this? See, you have to ask, otherwise it will be it will be difficult because it is already online. Hmm? If it is clear, can you design for length of the string divisible by 3? Divisible by 3. So mod W is divisible by 3. How do we write this mathematically? We write it like this: mod W equals to 0 mod 3. Right? Like this. Question can be asked like this also. So divisible by 3. Design it quickly. Think. Divisible by 3. Hmm? You can take an idea with this divisible by 2. That means even. What we are doing. Similarly, we can do something for divisible by 3 as well. Isn't it? Morning, sir. Similarly, we can do for divisible by 3. Yes. Come on. Okay. Divisible by 3 should include 0 or not? 0 is divisible by everything. Yes or no? 0 by anything is 0. What we want? We want that number mod 3 should be 0. Exactly. Correct. Correct. Anshi and Velaru is also correct. Correct. So most of you got this. For divisible by 3, what we have to do is a plus b, a plus b, a plus b, and whole closure. Yes or no? This is what is divisible by 3. Okay. Any issues till this point? Any doubt? Okay, you can copy this. I'll make it clean now. Next, try this. Mod W equals to or congruent to, both are same, equal to or congruent to 2 mod 3. 2 mod 3 means what? When we divide the length by 3, we should get remainder 2. Mod W congruent to 2 mod 3. Hmm? Simple, right? In this only what we can do. This is 0 mod 3. So for making it 2 mod 3, what we can do? We can add a plus b and one more a plus b. That's it. Done. Right? This makes it this 2 mod 3. This was a machine for 0 mod 3, right? What we have done? We have added 2 more a plus b. Then it becomes 2 mod 3, right? This is the regular expression for this now, right? Hmm? Is that clear? Let me know in the chat box quickly. Is that clear? Hmm? Quickly. I want responses. Let me know. Is that clear? Hmm. Okay. Thank you, Richa. So again, it will stop. The meeting will end in 10 minutes. So again, I'll start the same meeting like every day, right? So you have to join the same meeting. Okay. So if it is clear, then make whatever NFA or DFA we have designed, we can test for everything. Let's say number of A is even, let's say, or at least 2. Number of A is at least at least 2. Write a regular expression for this. Number of A is at least 2. And remember, the input symbols are A and B. A and B. Hmm? Number of A at least two. We are not talking anything about number of B's, right? We are only talking about number of A's. So what we can do, we can get at least two A's, and after that, whatever the number of B's we are getting, we don't care. In between these A's, we can get any number of B's, right? And then we can get any number of A's as well, right? So we can say that we can have any number of at least two. So more than two is fine, no problem. More than two is fine, no problem. Hmm. Is that clear? So any number of A's and B's can come, right? And then at least one A should be there. After that A, again we can have any number of B's, or zero number of B's are also fine. Then we have to have one A. Then any number of A's and B's, no problem, right? So basically this will cover the entire possibility of all the strings with at least 2A, right? Now at most 2A, or we can write it in many ways, uh, uh, like like we can write it like this. So we can start with B, or we can start with A, right? Then we can have B, then we can have A, and these A's and B's we can write together. Like we can write concatenation with A plus B closer, because A plus B closer is everything. A plus B closer is all possibilities of A's and B's, right? So you can directly write A plus B closer. So that will look more manageable. So at least two A's will be what? This. So before this A, I can have any number of B. Before this A, I can have any number of B. And after that, we can write this at the end also, right? That is also fine. It is not saying that in the beginning we should have two A's. We can have after A's and B's also, no problem, right? All these are same. You can write it anyways, right? As per your wish. Now, at most, number of A is at most two. At most two. Quick. At most two. Hmm? At most two. Okay. Richa has said A, B closer, and then B closer. A, B closer, A, B closer, and then B closer. She has kept in bracket, but it is not required. So, anyone else? Okay. Richa, can you tell me whether epsilon is valid in this or not? At most two. Can we get epsilon in this? Yes. So why don't you think in that way? You have to define something for epsilon as well, right? You are almost correct. I mean, uh, this B is not required here, because anyhow you have done this. If you put it here and you give some scope for epsilon, then it will be correct. So you have to do it like this. Any number of B's can come, and A or A can come or A cannot come also, because at most two A's are there. So I will write A plus epsilon. So this will give me an option for the A. I can have this A or I cannot have this A. Do you get this? Similarly, after this A or epsilon, I can have any number of B's. And then again, I am writing A plus epsilon. So I can have this A, or I can pass it on with an epsilon, right? So, and then we can have any number of B's. Do you get this? Everyone, do you get this? How we have written this? So at most 2A means we have to give option for A. We can either go through A, we can take A, or we can omit A, right? We can accept something without A as well, right? So that is both is possible. right? So this will be the regular expression for this. Hmm? Okay, any doubt? Please ask if there is any doubt. Everything is clear? Hmm? It is clear only to Risha. What about others? Is that clear, everyone? At most 2A. Hmm? Okay. Now, can you tell me, can we design for let's say number of A has to be even, right? So number of A has to be even. Number of A has to be even. What will be the regular expression for this? You are lost. Who is this? So, Inza, tell me how can I help? Uh, should I repeat something? Let me know. Ineza, I'm asking to you. How can I help? So can please revise how to make the regular expression. Okay. From the beginning. So you have attended yesterday's class, the night class, yesterday's night class. Okay. Still you have not understood. Let me explain. No problem. Let me explain. Just a second. Hello. Ha. See, Inza, a regular expression is a way of, first of all, keep on writing yes if you understand, right? So that we can make it a little quick. So, regular expressions are the ways of making or representing regular languages. Like if I am saying all possible, and how we are doing it. We are doing it with the help of four symbols, right? Four operators. So operands are strings, right? Strings like this A's and this B's, this epsilon, this phi. So what all strings are possible? We said there are possibility like anything which is there in the input symbol, like a, b, 0, 1, whatever in the question input symbol is given. So all these can come in the string. Along with this, phi can come in the string, epsilon could come in the string. So these are the operands. These are the operands in the regular expression. What are the operators? The operators are four. For this plus, this closer, these are in the power, and this plus and this dot, these are not in the power. These are between two things, between two regular expression, right? So ideally I should write it like this. I should write for the operands, I should write some regular expressions r1 to the power plus, some regular expression r1 to the power closer, some regular expression battery is low, okay, some regular expression. So ideally, I should say some regular expression to the power closer is also a regular expression. Some